We are again asked to find and sketch a domain. This time our function is f of x, y, z is equal to the natural log of 16 minus 4x squared minus 4y squared minus z squared. Since our function is a function of x, y, and z, our domain exists in R3. In particular, the domain is the set of ordered triples x, y, z such that 4x squared plus 4y squared plus z squared is less than or equal to 16. That's the case, of course, because the domain of the natural log has to be positive values. As far as sketching the domain, what I would be thinking about would be if we turn the inequality into an equation and divide by 16, then we end up with x squared over 4 plus y squared over 4 plus z squared over 16 is equal to 1, which we recognize to be an ellipsoid. So to represent the domain, we're going to draw an ellipsoid. We can go with traces in the coordinate planes as we did in a previous chapter, although we can streamline it by considering that since we have a term that's x squared over 4, we know that our ellipsoid will extend by 2 units at a maximum on the x-axis. So I'm putting points here at plus and minus 2 on the x-axis. Likewise, since we have y squared over 4, we're going to max out at 2 units away from the origin on the y-axis as well. The term z squared over 16 indicates that we're going to max out at 4 units on the z-axis. And so I'm going to draw, well, I'll do the best I can to draw an ellipsoid. Boy, that didn't work. Not including the boundary because of the inequality. Now I'm going to put some contour lines here on the ellipsoid. And the domain is the set of points that is interior to the ellipsoid. So what does the graph look like? Well, it doesn't have a physical representation. The domain is in 3 space, x, y, and z. And so I can just say that the domain is interior to the ellipsoid, but the function itself does not have a graph. We don't have a way to graph in 4 dimensions in most cases. So what does the function mean? I don't know. It depends on the context. It could be that the output is temperature for the points in the ellipsoid. I really don't know. It would totally depend on context. But this is the visual representation of the domain that we gave also using set notation. Next up, we are going to sketch the graph of a function. Our function is f of x, y is equal to 2 minus x squared minus y squared. And so we see the domain is in 2 space. Our function will be in 3 space. In fact, we can rewrite this equation as z is equal to 2 minus x squared minus y squared. We may recognize this equation as that of a paraboloid. And we could further say this paraboloid opens down and is 2 units up on the z-axis. At least that's where its vertex would be. So considering 2 units up on the z-axis, just drawing an inverted paraboloid. And then give it some dimension here so it looks like it's got a circular base. It should be a circular base because x and y have coefficients of -1. And I'm talking about a circular base, but in fact this extends down, right? There's no end to this paraboloid. I will give it, though, some sort of circular boundary down there at the bottom. That's a poor circular boundary because it doesn't look like the other circle that I drew. I'm just going to have to call it quits on that one. It intersects the xy plane at a value of square root of 2 along the x and y axes, but it continues down infinitely far. And there's the graph of our function. You know, I'm going to continue with the contour lines just to say, hey, this thing goes on. And there we go.